Sorry, 10. Did it ever go with 10? Can I erase it? I don't think it is. You guys, what do I have here? What is this? Product rule. What do I have here? Product rule. Put that 2 somewhere. Before you do product rule, do product rule. Put that 2 somewhere. Before you do product rule, set up the product rule. X squared prime times y plus the first times derivative of the second, and then for the other one, derivative of the first times the second plus the first times derivative of the second. I'm just going to do the other side. This is product rule for the first piece. This is product rule for the second piece. Derivative of the first times the second plus the first times derivative of the second, and I just wrote it out in my boxes first. And then I'm going to take the derivative. Derivative of x squared is 2x. Y plus x squared times the derivative of y is what? Y prime. Great. Plus the derivative of 2x is 2. Plus 2x times the derivative of y squared. 2. Bring down the 2 power rule. Raise to the 1 times the derivative of what's inside. What a hot mess this just became. But it's the same. Anything with a y prime, bring to one side. Anything without a y prime, bring the other side. Is this getting too dark? Want to turn one of these lights out? It's a little too dark. Why don't you guys nap it? Watch those eyeballs. Here we go. 3, 2, 1. That's it. We have it now. Okay. Let's see. I see a y prime on this thing. This whole chunk of junk. You see it? This whole thing and this whole thing. Those I'm going to bring all to the left or to the right, whichever one you prefer. Any chunk of junk with a y prime in it, I'm going to beep, boop, pop, bring it over to the left. There's one chunk of junk. I'm going to subtract it from both sides if it's not already there. Anything without a y prime, I'm going to bring to the other side. This 2 times x times y, you're out of here. 2y squared, I will see you later. Huh? Yes. Because it doesn't have a y prime in it. See ya. See when I'm famous, 2y squared. That's what John Mayer wrote in his yearbook. It's true. So then this all simplifies to 4 xy y prime minus y prime is equal to, subtract this. Subtract this. This stays here. In any order. Again, you guys can be wherever they want. As long as this thing's negative, and these are all added together, but as long as this is negative and this is negative, it can be in any order. Same thing over here. Does that make sense, guys? As long as they're all there, you're all good. Factor out a y prime. Parentheses, x squared plus 4xy minus 1 equals negative 2xy minus 2y squared plus 1. feeling so far? Silence isn't good. Silence. How's it going so far? Where we at? Questions. Ask questions. Ask the questions. Whatever's in your head, why don't you just ask it?
Yeah.
The question that's in your head right now. Eve!
How do you get from like 2y squared plus?
Which line? This one?
Third line.
This one?
To 4xy times y.
So this is all. This whole chunk is all multiplied together. This is 2 times x times 2 times y prime. Commutative property, since it's all multiplied, you can multiply them in any order. Just like 5x is the same as x times 5. It's the same thing. You know what I'm saying? So then you can combine these two things. Just like x times x times x, you can take those x's and say x cubed. Okay? So y prime equals negative. Y prime equals 2xy plus 2y squared minus 1 all over 1 minus x squared minus 4xy. Right? Is that what you got? I explicitly. What's that? Did I? Did I change the sign? What did I just do, you guys? So you're going to get all this problem. You're going to get something that looks like negative 2xy minus 2y squared plus 1 divided by x squared plus 4xy minus 1, yes? And you have this as your answer at choice C. And you're like, my answer is not there. Why is this the same? Well, I multiplied the top and the bottom by a negative 1. You see that? If you multiply the top by a negative 1, all the signs will change. If you multiply the bottom by a negative 1, all the signs will change. If you multiply the top and the bottom by the same thing, you're not changing it. Does that make sense? This is the same. This is the same as negative 2xy minus 2y squared plus 1 over x squared plus 4xy minus 1. Does that make sense? And are you fine with that? Because this is what might show up. It's like, oh well, I did all the hard work and recognize it's the same. Okay, Rafi? Questions on that? Is that a move on, or is that I don't know what just happened? Okay, let's move on. 12. We've taken the derivative in terms of t before. We've taken the derivative of x before, well, in terms of x before, but this is, again, you want to take the derivative in 12 in terms of x. So you would treat the t as a y then. You're still ddxing both sides of the equation. ddx, both sides of the equation for sine xt equals t. That's a t and that's not a 1. Sine xt is equal to t. Try to work it out in your groups. Do a line and check it. Are you doing it correctly? Some groups are checking, some aren't. Check. Do one line and check with the group. Am I doing this right? ddx both sides of the equation. What did you do? How did you start ddx in both sides of this equation?